So this video is to help us remember how to factor polynomials. So if we have some polynomial, we can pull out or factor out a 4. And when you pull a 4 out of 4x, you're left with an x. And when you pull a 4 out of a 12, you're left with a 3. So in this case, 4 and 3 are both factors of the 4x plus 12. And 4 times 4x plus 3 is called the factored form of 4x plus 12. If we have some polynomial that we cannot factor, then it is called a prime polynomial, which in other words means it's not factorable. We always make sure that when we are factoring that we factor completely. So we'll factor everything all the way out. And the number one rule of factoring there's lots of different factoring patterns. But the first thing you always want to do is always look for that GCF, that greatest common factor, and pull the GCF out. So let's try these examples of pulling out just the GCF. So if we look at letter A, I'm going to rewrite this. This is really 9. Y to the fifths means that we've multiplied y by itself, or times y, 5 times. So 1, 2, 3, 4, 5. Plus, don't forget in front of this y squared there's a 1. So plus a 1. And then y squared means y times y. So when we are factoring polynomials that have both a coefficient piece and a variable piece, I do them in different parts. So the first thing I do is I look at the numbers, the coefficients, 9 and 1. 9 and 1. So 9 can be 1 times a 9 or 3 times a 3. But 1 is only 1 times 1. So the GCF of 1 and 9 is just 1. It's the biggest number that goes into both of them. So we're going to pull out a 1. And then I'm going to look at the y's. We're going to pull out as many y's as possible, but you can't pull out more y's than exist. So if you look at the second term, the most y's here is 2, and the most y's here is 2. So I can pull out a y times a y, which we call as a y squared. Now we're left with right here, y cubed. And right here, there's always a 1 placeholder. So we're left with a parenthesis. Don't forget about the 9 out front because we pulled out a 1. So 9 right here divided by the 1 that I pulled out is 9. And then y cubed, right here, this y cubed that was left, plus 1 right here divided by the 1 out front is a 1. We need that for the placeholder, and there's no letters left here. So my cleaned up answer is y squared, 9y cubed plus 1, parenthesis, here's my answer. And one of the beautiful things about this and math in general is that you can always check your answer. So y squared, 9y cubed plus 1. And then we just distribute in, and then 9y squared times y cubed. Remember, you add your powers as y to the fifth, plus 1 times y squared is y squared. And this right here with the red dot is the same thing that I started with right here. So we did the problem correctly. Okay, let's try the next one. So in the next one, I'm going to draw it out again. I have 6x squared means x times x, and then a t, plus an 8xt minus a 12t. I'm going to go over here for a second. 6, 8, and 12. So 6 has factors of 1 and 6, 2 and 3. 8 has factors of 1 and 8, 2 and 4. 12 has factors of 1 and 12, 2 and 6, 3 and 4. There's no 4 in 6, so I can't use the 4. There's no 6 in 8, so I can't use the 6. 12 is the one that has a 12. And so if you look what's left over, don't say 3. There's no 3 in the 8 either. So the biggest number they all have in common, the greatest common factor is 2. They all have a 2. So I'm going to divide each number by 2. So when you pull the 2 out front, it's like you're dividing each one of these by a 2. Now we're going to do our letters. They all don't have an X, so I can't pull any X's out. But they all have a T. So I'm going to put this T out front. 6 divided by 2 is 3, and then x squared, plus 8 divided by 2 is 4. I pulled the T out, so I'm left with an x, minus 12 divided by 2 is a 6. And then there's no letters left there. So our answer is 2t, 3x squared, plus 4x minus 6. The last one might look a little scary, and that's okay. We're just going to draw it out. So we have 14 m plus 1, and it says m plus 1 cubed, so I need to write m plus 1 3 times, minus 28 m plus 1 minus 7 times m plus 1. Okay, over here to the side, I have a 14, a 28, and a 7. So the easiest thing, in my opinion, is to go to the smallest number you have and see what its factors are. 7's prime, so its only factors are 1 in itself. 7 goes into 14, and 7 goes into 28. So I'm going to pull a 7 out of all of them. So I'm going to divide a 7 into all of my numbers. So I put the 7 out front. Now if you look, this has an m plus 1, this has an m plus 1, and this has an m plus 1. So I'm going to put a m plus 1 out front. And then I'm going to write down what's left. So 14 divided by 7 is 2. And then I have m plus 1 squared minus 28 divided by 7 is a 4 times an m plus 1. And then negative 7 or 7 divided by 1 or divided by 7 is a 1, so minus 1. There's no letters left there because the letters are in the front. I pulled them all out. Now, technically speaking, this is our final answer, except we probably should clean it up. We always clean our answers up in math, so let's clean this up. So I'm going to take care of this piece first. That means m plus 1 times m plus 1. So when you FOIL this, you should get m squared plus m plus m plus 1. There's a 2 in the front. So that piece is 2m squared plus this right here is 2m's. So now I have 4m plus a 2. I'm going to take this negative 4. I'm going to distribute it into everything. So I get minus 4m minus 4. And then minus 1. Now we're going to remember not to drop this off. We're going to need that. But right now we're just cleaning up inside our big black parentheses. So my positive 4m and my negative 4m can cancel off. So I get 2m squared. Plus 2 minus 4 is a negative 2. Minus 1 is minus 3. And then I said don't forget this, so you have 7 times m plus 1. This is your final cleaned up answer. Okay, here's another special factoring pattern. When we factor by what's called grouping, factor by grouping happens when you have an even number of terms. So if you look right here, in this expression, I have 1, 2, 3, 4 terms, and we make groups. And when we make those groups, every group has to have the same number of terms in it so that we can make nice, pretty, even groups and teams. So let's go ahead and try a few problems. So if you look at letter A, I'm going to have 2 teams. I'm going to call them my red team and my blue team. And you don't always have to group them the way they're written. You can reorder them, but we'll see if this works this way. So in letter A, my 2 red things, they both have an M in common. So once you make your teams, you're going to pull out what we did on the previous slide. We're going to pull out their GCF. So these 2 have an M in common. I'm left with p squared plus 7. In the blue group, they both have a positive 3 in common. And then I'm left with, a p squared plus 7. So when you factor by grouping, the whole goal is that the 2 things right here that I'm highlighting in yellow, they should be the same, because now both of these terms, my red term and my blue term, they both have the parenthesis p squared plus 7. So from both of these things, I'm going to pull out a GCF again of this p squared plus 7. And then left in my red team, parenthesis, my red team has an m left, and my blue team has a plus 3 left. And now we have factored by grouping. So before I start this problem, remember how I said a couple seconds ago that you don't always have to group the way they are? If you look at these 2, those 2 things don't really have anything in common. One has a 2, the other one has AZ, but the first one has Y. So we probably need to regroup. So let's try that. Let's try regrouping. The whole importance in regrouping is that you just make sure their signs stay where they belong. So let's do that. So let's try putting the Y's with the Y's. So I'm going to write 2y squared. That's this one. This one's a minus. Minus ay squared plus az minus 2z. Now I can try to make my groups. So I have a red group and a blue group. In my red group, they both have a y squared. 2 minus a is left. In my blue group, they both have a plus z. And then I have a minus 2 left. Now I said earlier that when you factor by grouping, these things in parentheses, they need to be the same. It's the whole point of the factor by grouping. So let's try going back one step. And I'm going to reevaluate just the blue piece right here that I'm boxing in green. Let's look at this one more time. Instead of pulling out just a z, let's try pulling out a negative z. That makes the a become a negative a, and it makes the 2 become a plus 2, which I can rewrite. Negative z, I'm going to write them in the right order. So positive 2 minus a, and now y squared, 2 minus a. Now my things in parentheses match. So I'm going to pull out or factor out what I had in parentheses. The 2 minus a, that's gone and this is gone. And in the red terms, I'm left with a y squared minus z from what was the green-blue team. And so here is your answer. Okay, another one. So let's make our groups. Red group, blue group, In my red team, they both have a 2 and an x squared. 4 divided by 2 is 2. That was an x cubed, and I pulled out 2 of the x's, so I'm left with 1x here. And I pulled out, air quotes, everything, so I need to put a 1 there for the placeholder. I'm going to pull out a -1, because do you see everything in my red parentheses right here? All this is positive. Well, that means these parentheses over here that I'm about to draw, I need them to be positive. So I pull out a -1. Oops. And then this becomes a 2x, a positive 2x, so I pull out the negative, and a +1. Now my things in parentheses match, so I can pull that parentheses thing out front. 2x plus 1. And I'm left with a 2x squared minus 1. And there's your answer. Okay, so now we're going to factor trinomials, the thing that we are probably the most used to factoring. And just a little thought or a little tidbit. In the last section, we talked about doing FOIL and multiplying binomials together. That is how we undo our factoring or check our factoring. So if we look right here, if I FOIL this, FOIL, or multiply together, I should get to this. And when I go this way, what I'm doing is I'm going to factor. So I'm going to take the multiplied out version and factor it into normally some kind of binomial. Not always, though. So there's lots of different ways to do this. You may have learned something called the box method. I'm going to do what's called, I guess, the A times C method, but what it uses is the factor by grouping that we did in the last page. So what I'm going to do is I'm going to do A. Oh, hang on. Let me write this down so you know why I'm calling it A. When you learned about quadratics, you called them ax squared plus bx plus c. So the leading coefficient we called a, and the constant term at the end was called c. So I'm going to multiply a times c together. So I go over here. I'm going to do the leading coefficient a times c, and I'm going to get positive 24. So I'm going to go over here. I'm going to write down 24. I'm going to write down all of its factors. 1 and 24, 2 and 12, 3 and 8, 4 and 6. And then when I say 6 and 4, you can stop because 6 and 4 is the same thing as 4 times 6. Because this middle term is negative, but this right here is a positive, I need to take these numbers. When you multiply together, so I'm going to do green. When they multiply, they must equal the 24, this thing right here. But when they add, they must equal what we call the b term, this b, the middle number. So I need them to multiply, in this case, to be a positive, but add to be a negative, which is our negative 11. The only way that I can multiply to be a positive and add to be a negative if they're both negative, because a negative times a negative is a positive, and a negative plus a negative is just going to be a more negative. So now that I have the signs written in, I'm going to go through and figure out which pair adds up, because they all multiply to make positive 24, but which pair adds up to make my negative 11, and it's this third pair down that is my winner chicken dinner. So I'm not changing anything. I'm literally rewriting the trinomial into a polynomial with 4 terms. So I get 4y squared minus, I'm going to do the 8 first because 8 and 4 have more in common, minus 8y minus 3y plus 6. And the 3 and the 6 have more in common. So I'm going to use 2 colors like I did before. I can't use blue because I wrote in blue. But I'm going to make 2 groups. I'm going to have a red group, and we'll use a green group. In the red group, they both have a 4y in common, and you're left with y minus 2. In green, they have a minus 3 in common, and you're left with y. Be careful. Positive 6 divided by a negative 3 is a negative 2. And now Sorry, let me fix the colors. And now my two parenthesis groups are both y minus 2. So now I can factor out the y minus 2 that both groups had, and then I'm left with a 4y minus 3. And there is our factored version. Let's try it again. So our process was that we take the first term times the last term. We're going to do 6 times, it's a negative 5. That's going to make a negative 30. So I go over here. I have a negative 30. I'm going to write down my factors first. 1 and 30, 2 and 15. Excuse me, 3 times 10. 4 doesn't go in there. 5 goes in there times 6, and then 6 times 5. Okay, this time I have to multiply to be a negative. Do you see how my number at the top's a negative? Because I have to multiply to be a negative, one of my terms has to be negative, but the other one has to be positive. The only way you can multiply two numbers together and be a negative is if only one of those two numbers was a negative. So in fancy math terms, if a times b equals a negative number, only one, a or b is negative. Not both, just one of them. And the way we tell which one very easily is we look at our middle term right here. Do you see how my middle term is negative? Since my middle term is negative, I need my bigger numbers to be negative, because when I add them together, when I add these pairs together, I need to end up being negative, which means the bigger one needs to be negative, so when I add together, I stay negative. So if I had made my smaller one negative, for example, if I had made 2 negative, negative 2 plus positive 15 would have been a positive 13. I would never make it to that negative. So my winner here is the 3 and negative 10, because those will add to make a negative 7. So let's rewrite what we have now. 6p squared plus 3p minus 10p minus 5. And if you're confused what I say by I'm not changing anything, I'm just rewriting it, the 3p and the negative 10p, if you combine those like terms, you will get back to the negative 7p that I had originally. So I'm not changing anything. I'm just disguising it, rewriting it, however you want to phrase it, so that I can have 4 terms to make my red group and my blue group. So in my red group, we have a 3 and a p in common, and I'm left with 2p plus 1 when I pull out that GCF. In my blue group, we have a minus 5 in common. I'm left with 2p and a plus 1. My parentheses are the exact same as they should be. So now I get 2p plus 1 from both the red and the blue groups. And then I'm left with a 3p and a minus 5. Okay, let's try again. So we take our a times our c and we get negative 36. So negative 36. My factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Because it's negative, one of them has to be negative, just one of them. And my middle term this time is positive, so that tells me that my smaller ones are going to be the negative, and my bigger ones are going to be the positive. So here's my pair, here's another possible pair, another pair, last pair. So when I add these up, this adds to 0. This one adds to positive 5. This one adds to positive 9. This one adds to positive 16. And this one adds to positive 35. None of those are my 13, which means that this is not factorable. Which we also can say is a prime polynomial. Okay, let's try one more. So when we started, I said the number one rule of factoring is the GCF. So before you try factoring anything, remember, you should always pull out your GCF. So if you look, 16, 24, and 16, those are all even numbers. They have at least a 2 in common, maybe bigger. So I'm going to go over here. I have 16, 24, and another 16. So I just 16 and 24. So let's list their factors. 1 and 16, 2 and 8, 3 doesn't go in there, and then 4 times 4. 4 times 4. If I go over here, 1 and 24, 2 and 12, 3 and 8. Okay, well, I've already passed 16, but we both have an 8. So I'm going to rewrite this first of all. I'm going to put an 8 out front, and I'm going to do 2. And then we should also see, I almost totally missed it, but almost. They all have at least one y. So I'm going to put that y out front. And then I have 2y squared plus 24 divided by 8 is a 3y, because I pulled one of the y's out, and then minus 2. Now I have to check that this trinomial factors. So we're not going to lose this. We're going to put it over here in timeout for a second. We're not going to lose it, but we're going to focus on this. So 2y squared plus 3y minus 2. So we're going to do our a times c. 2 times negative 2 is a negative 4. Negative 4's factors are 1 and 4, and then 2 and 2. I need it to be negative, so one of them has to be negative, and it's going to be my smaller one because I need it to add to a positive 3. So this is the pair that I want because negative 1 plus 4 is going to make my positive 3 in the middle. So 2y squared minus y plus 4y minus 2. Red group, blue group. Red group has a y in common, so you pull out a y and get 2y minus 1. Blue group has a plus 2 in common, so they're going to have 2y minus 1. Both groups have the same thing in the parentheses, the 2y minus 1. So we're going to write down parenthesis 2y minus 1 from both of them. And then y plus 2. And then I told you we won't forget about this. We have to put our 8y in the front. So here is our completely factored version. Okay, so we're going to look at some special factoring patterns. We'll look at these when we foiled, and now we're going to use them again only to factor. So just something to recognize is that when we think we might have a perfect square trinomial, first of all, sometimes I have two different variables, but what really gives it away is that first term and that last term are squared with a singular middle term. And we can prove these factoring patterns. We can go x plus y times x plus y. And we can do a FOIL. X times x is an x squared. X times y is an xy. Y times x is also called xy. Remember, we always write them in alphabetical order. Y times y is called a y squared. There's two of these middle terms, so this becomes an x squared plus 2xy's plus y squared. You can do the same thing with the minus version. So to undo this, we just need to know the pattern or recognize that it is a pattern. So if I'm going to do that, this term right here is a y squared. This term right here is an x squared. So if I use a mathematical sentence, I know that 25q squared equals y squared, and I want to have a y to plug it back into my formula. So if I square root this, we know that 25 squared is, square rooted is 5. Q square rooted is q, so this is my y. Same idea here. We're going to square root 16 and get 4. P squared square rooted is just p. Once you know your x and your y, you can write down that you look right here. Do you see where this is a negative? So we're going to use one with a minus in the middle. And it's always x, y, and the square on the outside. If this had been a plus right here, then my middle term here would have turned into a plus. So my x is a 4p, my y is a 5q, and that is all you have to do to recognize that it's a factoring pattern. So if we go over here to the next one, it may not be as obvious as a factoring pattern, but 49 is a perfect square. It is something squared, so that it is a square. And all of these terms right here, 36x squared, y squared, that is also all perfect squared things. So we know that y equals 7. X is going to equal the square root of 36 is 6. The square root of x squared is x. The square root of y squared is y. And because my middle term is a plus, I'm going to do x plus y in the square on the outside. So I get 6xy plus 7 and then squared on the outside. Let's look at some more special factoring patterns. Okay, the first one I hope is kind of familiar. This one right here. Let's say I do x squared minus 4. Both of those are perfect squares. This factors into x plus 2 and x minus 2. Because when we FOIL this, x times x is x times x squared. X times negative 2 is negative 2x. 2 times x is plus 2x. And 2 times negative 2 is negative 4. Because of the sign difference in the middle right here, these two will always cancel out, leaving us with an x squared minus 4. The sum and difference of cubes seems to always be a little treacherous, but I'm going to hope this is going to help. Right here, I need you to remember this acronym, SOAP. We're going to wash it up and clean it up, and we're going to use some soap. So here's the pattern. If you look here, it's always the same sequence of letters. So I was taught this silly little story that x and y were hanging out together. X got squared, x tagged y, and then y got squared. And then we're going to SOAP. So when we SOAP, SOAP stands for same, opposite, and the last two stand for always, positive. If you look, this last term in both of them is always positive. So this last one is always a positive. Always sunny and positive. Same means it's the same as the sign that it was. So for example, when I do the sum of cubes, same means the first one is a plus, and then the next one opposite would be a minus. But in difference of cubes, same for the first one means a minus, and then opposite means a plus. So we're going to use that in a second, and then hopefully we can remember the pattern. Okay, let's do the squares ones first. So the dead giveaway in letter A that it's a difference of squares is that there's only two terms, and they're both perfect squares, and there's a difference, a minus in the middle. So this is my x squared, and this one right here is my y squared. So we're going to square root again. X equals square root of 4 is 2, and then m, and y is going to equal the square root now, which is 3. So this is, remember the pattern was x plus y, x minus y for x. When I have something x squared minus y squared, this is where it came from. So I'm going to get 2m plus 3 and then 2m minus 3. Let's do that again. So this is something squared minus something squared, dead giveaway that it's the difference of squares. And this factors into x plus y times x minus y. So this term is like x squared. So to find x, I have to square root this term. So x is going to equal 16k to the 16k squared, square root this, and then y is going to equal 25m squared. And then I'm going to plug it into my pattern over here. So it factors into 16k squared plus 25m squared times 16k squared minus 25m squared. Okay, we're going to do it again. The next one looks a little bit different, but it's not. This right here is an x squared. This right here is a y squared. It factors into x plus y times x minus y. We just need to figure out what x is. See the squares? So this thing right here is x. X equals a plus 2b. We have to square root this piece to find y. So y is going to equal, the square root of 4 is 2, and then the square root of c squared is just c. And then we can plug it into our pattern. A plus 2b plus 2c. A plus 2b minus 2c. The next one is a little bit tricky. This y at the end seems to be the oddball out. So I'm going to deal with just this for a second. So x squared minus 6x plus 9. Remember, there's an imaginary 1 here. And we can factor this we did earlier. If you can't see what it factors into, but we can do this. 1 times 9 is 9. 2 factors of 9 that make 6. Well, 3 and 3 make 6. They need to multiply to be a positive 9, but add to be a negative, so negative 3 and negative 3. So x squared minus 3x minus 3x plus 9. Then you make your groups. The first group has an x in common, and you're left with x minus 3. The second group has a minus 3 in common. You're left with x minus 3. Both of them have an x minus 3 that we have to pull out, x minus 3. And then in the first group, I'm left with an x minus 3, which we can rewrite as x minus 3 squared. So this piece right here, I'm going to write as x minus 3 squared minus y to the 4th. This is my x squared minus my y squared. X equals x minus 3. Y equals y squared. And just square root the y to the 4th to get to my y squared. And then we use our factoring pattern, x plus y times x minus y. And I get x minus 3 plus y squared times x minus 3 minus y squared. And then letter E. Letter E is a lot like letter D. The y thing right here is the only weird one. So I'm going to rewrite this. I'm going to write it as y squared. I'm going to pull out a negative, so minus x squared. I pulled in a negative, so it became a positive. If I pull out a negative, this becomes a minus 6x and a plus 9. And this thing I'm underlining in blue is the same thing that we had that over here in this other problem. Right here, it's the same thing. So we know that that piece factors into x minus 3 squared right here. So I have y squared minus x minus 3 squared. Y squared minus my x squared. And in this case, y equals y. X equals x minus 3. So when I plug it in my x plus y, x minus y, I get y plus x minus 3, y minus x minus 3. And there's my answer. That was a whole bunch of algebra. And now we're going to go back and use from the previous page the sum and difference of cubes to factor. So I want to write on this page, just one time, I want to write the sum and difference of cubes. So the factoring pattern was x, y, x squared, x tags y, y gets squared. And your signs, we're going to do SOAP. And this is going to look like x cubed plus or minus y cubed becomes this thing down here. So if you look right here, x cubed plus this is something cubed. We'll call it y cubed. So to find out what that something is, we're going to cube root them. So if I cubed root and cubed root, x is going to equal x. The cubed root of 27 is 3. So my pattern was x, y, x squared, x, y, y squared. So x was called x, y is 3, x squared, 3x, and then y squared, or 3 squared is a 9. And now we do the SOAP piece. SOAP stands for same, opposite, always positive. So the sign I started with right here with a plus. So to be the same, then this would be a plus. Opposite would be a minus. And the last part stands for always positive, plus. So let's try it again. So this is x cubed minus y cubed. So I cubed root both of these to find out x. So x is going to equal m, and y is going to equal, the cubed root of 64 is 4, and then n. Cubed root of n cubed is n. So my pattern is x, y, x squared, x times y, y squared. So my x is called m, my y is called 4n, m squared, 4 times m times n, because we put them in alphabetical order. At the end down here, be very careful. We have to write 4n, and the whole thing needs to get squared. So, and then we have to SOAP. Let's write this one more time. I'm going to have m 4n, m squared, 4mn. Before I SOAP, 4n squared is 16n squared, because you have to square the whole thing. And then we SOAP. So same stands for minus this time, so minus. O stands for opposite, so this is going to be a plus. And the last two, AP, stand for always positive. So here's your answer. I'm going to copy this one down right here, the letter C that we haven't done yet, because I'm running out of room. So let me just copy that down real quick. So letter C is 8q to the 6th plus 125p to the 9th. This is x cubed and y cubed. So I need to cube root them. So if I do the cubed root of 8q to the 6th, what times what is 8? Well, that's a 2. And in case you don't remember or understand where this is coming from, what I'm really doing is the power on the q, which is 6, divided by the root, which is 3. And so this is 2. 6 divided by 3 is 2. So this is 2q squared. This is going to be my x. 125p to the 9th. Got to take the cubed root so I can find y. The cubed root of 125 is 5, and then q to the 9th divided by the 3. It's the power divided by the root. Here's my power. Here's my root. Well, 9 divided by, oh, this is a p, sorry. And this p stands for power. 9 divided by 3 is 3. So this is my y. So now that I have my x and my y, I can do my x with y. X squared, xy, y squared. It's going to be 2q squared, 5p cubed. Be careful, you have to square the whole thing. So it's going to be 2q squared squared, 2q squared, 5p cubed, and then again, be careful, 5p cubed squared. So this is going to be 2q squared, 5p cubed. 2 squared is 4, q squared is q to the 4th. 2 times 5 is 10, and we write in alphabetical order, so p cubed, q cubed. And the last one, 5 squared is 25, p to the 6th. And then we soap. I started with a plus. Same, opposite, always positive. Okay, one more special factoring. Okay, the last little factoring trick or pattern that we have really isn't a pattern. It's more of what I refer to as a disguise, because we're going to disguise something to make it easier. When I look at letter A, it's a whole bunch of stuff going on. And so if I take this piece right here, the 2a minus 1, I'm going to let this be called, sometimes this is called u substitution, so I'm going to let this be called u. I'm going to rewrite this. This is 2u squared minus 19. Remember, I called 2a minus 1 u, and then minus 15. This now looks like factoring trinomials that we did earlier in this video, where I do the a times the c. So 10 times negative 150 is, 10 times negative 15 is negative 150. And then if I do negative 150 and I list the factors, it's not going to be 1 and 150, 2 and 75 is too small, 3 and 50 is too small, 4 doesn't go in evenly, 5 and 30 doesn't work. I'm going to try 6 and 25. I think I can make 19 out of 6 and 25. So remember, it's negative, and then if you look at 19 right here, it's negative, so I need the bigger one to be negative. A negative times a positive is going to make a negative 150. A negative 25 plus 6 is going to make my negative 19. So I'm going to go back over here and I'm going to write out 10u squared minus 25u plus 6u minus 15. I haven't changed the 19. If I add these two back together, I will get back to my negative 19u. Then I make my groups. Here's a red group and a blue group. In my red group, those both have a 5u in common. I'm left with a 2u minus 5. In my blue group, those both have a 3 in common, 2u minus 5. And then both groups match. They both have, in the parentheses, the 2u minus 5. So 2u minus 5 out of both. And then I'm left in red with 5u plus 3. But you've done all that work, and you're not quite done yet, because we have to replace the u back with our a's. So I have 2 times, u was called 2a minus 1, and then minus 5. 5 times 2a minus 1 plus 3. I'm going to distribute my 2 into this set of parentheses and my 5 into this set of parentheses. So when I do that, I get 4a minus 2 and then minus 5. And I get 10a minus 5 and then plus 3. And now I'm just going to combine like terms. These two have a combined like terms. A negative 2 minus 5 is a negative 7. So I get 4a minus 7. And then times, I can put these together and I get 10a minus 2. Don't box. This is a little warning. This and this don't have anything in common. 4 and 7, 7's prime. There's no 7 inside of a 4. That's good. However, these two, 10 and 2, have a 2 in common. So what we need to do is pull a 2 out of them and make this become a 5a minus 1. Because when we factor, we have to factor completely. So this piece is now this. So I'm going to take my 4a minus 7, and then my cleaned up blue piece, I'm going to put the 2 in the front, and then write 5a minus 1. Here's my final answer. Okay, let's try the next one. So what do we think we should call the u in this case? I'm hoping you said should be the u. So we're going to let u equal 2a minus 1. So I can write this as u cubed plus 8. This is like an x cubed plus a y cubed. So I can cubed root both of these. X is going to be called u, and y, the cubed root of 8, is 2. This is the sum or difference of two cubes. We know that x cubed plus y cubed factors into xy, x squared, x tags y, y squared. So if I plug our stuff in, our x is called u, our y is called 2. U squared is u squared. U times 2 is what we call 2u, and then 2 squared is 4. And then we do the soap. I was a plus, a plus, a plus. Same, opposite, always positive. Okay, one last time. So this one is where U substitution really is seen a lot. We don't factor normally with a z to the fourth in a trinomial. It's not something we've seen a lot. So this one, it's helpful to go to the middle term. Let this one be called U. So if I let U equal z squared, if I then square both sides, then U squared equals z to the fourth, which means this z to the fourth I can now call U squared. So I have 6U squared minus 13U minus 5. I do A times C and get negative 30. Negative 30's factors are 1 and 30, 2 and 15, 3 and 10, 5 and 6. Because the 30 up here is negative, one of these has to be negative. And because it adds to a negative, it's the bigger one that's negative. If they added to make a positive, then the bigger one would be a positive. Pair, 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 pair. Although 3 and 10 are very tempting to make the 13, those will not make it because 3 plus negative 10 is actually negative 7. So it's this pair right here that I want. When I rewrite this, I get 6U squared plus 2U minus 15U minus 5. Red group, blue group. In my red group, we have a 2U in common. 3U plus 1. In my blue group, we have a minus 5 in common. 3U plus 1. Both of their parentheses match, so I pull out from both red and blue groups 3U plus 1. In the red group, I'm left with a 2U and a minus 5. And we're so close to being done. So close, but I have to plug back in what I started with. This one's not nearly as bad as plugging back in. Remember we let U equal z squared? So we write 3z squared plus 1, and then 2z squared minus 5. And now that I've said that, I'm pretty sure in the last problem I forgot to go back and plug back in the U value. So let's go back and do that and finish that problem again. Yep, I forgot. My fault, guys. I'm so sorry. So let's go back and finish this problem.
What are you talking?
So we have to go back and replace. Remember, in letter B, my U was right here. 2a minus 1. So 2a minus 1 plus 2 times 2a minus 1 squared minus 2 times 2a minus 1 plus 4 . So this one I can combine like terms. This is 2a plus 1. This piece I have to physically square. I have to do 2a minus 1 times 2a minus 1. Which is going to get me 4a squared minus 2a plus 1, which is the same thing as 4a squared minus 4a plus 1. This piece, I'm going to distribute the negative 2 into and get negative 4a plus 2. So let's put this all together. This piece, the 2a plus 1. Then I have the red, the 4a squared minus 4a plus 1. Then I have to grab my green stuff, minus 4a plus 2, and then this 4 at the end, plus 4. Okay, let's combine like terms. Negative 4a and negative 4a. One, 3, and 4. 2a plus 1 squared. 4a squared minus 8a plus 7. And then that is my final answer. Sorry for forgetting to plug that back in.